Welcome everybody to another session of ZEDEDA Transform. This is the Secure Industrial IoT Router and Workload Consolidation track here. We've got a great lineup of speakers today. Myself, I'm John Auld from ZEDEDA. I am a sales director with our team. I came here about a year ago on this journey. Before this, I spent about 20 years with Siemens on both the IT side and the OT side. And to start this off, I'd like to do a quick round of intros of our speakers for the audience. Maybe we could start with Tim at Lanner.
Hey guys, Tim Casto with Lanner Electronics, working out of the Boston area. I've been with Lanner about 2 years, but been in the industrial telecom networking space my whole career, really enjoying bringing new technology to customers. And what's exciting about Lanner is it's really a hardware-centric company, and we need to partner with software providers like ZEDEDA, VyOS, and Nozomi to create solutions for the space that we're talking about today.
Thanks, Tim. How about Taras?
Hello all, I am Taras Podyak, network engineer at Centrium company that develops VyOS software router. I'm working here for the past 2 years, and being the part of open source community and improving this all business section and routers is really exciting.
Thanks, Taras. And finally, Phil from Nozomi.
Hey guys, my name is Phil Page. I'm from Nozomi Networks, and I am the Director of Partner Technologies here. So I've been working with ZEDEDA, as well as the rest of our partner ecosystem, to put together cool solutions like the one we're going to show you today. So happy to be here.
Thanks, Phil. So I'll do a brief intro to this session that we'll talk about today. Again, it's industrial IoT router and workload consolidation. So the key to this session is many companies go through digital transformation. They ultimately get to the tricky divide that bridges IT and OT networks, which is referred to as the IoT edge. As we get to this space, we begin to see the need for several architecture elements that provide different layers of security, networking, and other various applications. The traditional way of navigating this space was dealing with this complexity would be to deploy single focus hardware solutions for routing, networking, and security, as well as various other applications. So today, we're going to look at, with our partners, a modern way to go about this in deploying a secure industrial IoT router that consolidates networking, security, and application functions in a modern stack. And so, briefly, here's an architecture shot of how these pieces come together. We'll have each of our partners talk about their specific space, but Lanner provides the platform itself. The team at VyOS will talk about the software switch and router discussion, and then with Nozomi and the security piece of it. So to start the session off, I'm going to introduce Tim Castro with Lanner, and he's going to kick off the discussion. Stage is yours, Tim.
All right, thanks, John. I assume everybody can see the large screen, not the tiny microscopic screen that we see. That would be great. Yeah, so essentially this is a workload consolidation effort created by putting a virtualization layer, an orchestration layer of software that ZEDEDA provides on top of a multi-core industrial PC, edge product, or rack mount server. And so the ZEDEDA software then accesses all the hardware resources and provides a set of containers or virtual machines that various applications can sit in, whether it's Linux-based or whether it's application-specific, like VyOS or like Nozomi. And so each of those can run independently. Multiple copies can be spun up or spun down. Workloads can be added and dropped as needed. And what's neat about it is you can deploy this in a scalable way throughout the entire ecosystem, the entire plant, the entire grid that you're talking about with network management features. So Lanner develops the hardware for these sorts of solutions. We're a hardware-only company. So let's flip to the next slide for a brief intro of Lanner. So Lanner develops hardware solutions. We're a $250 million company that the common elements of whatever we build, whether it's for the grid, the industrial sector, transportation, a security network, enterprise, or telco, comprises of compute elements, security elements, and networking elements. So the security that we're talking about is not simply a software layer or a packet layer or a cloud layer, but it's actually embedded down at the hardware. So whether it's TPM or whether it's secure boot or whether it's lockdown BIOS and firmware, the hardware underneath everything is secure. So these are common elements in all of Lanner's products, whether they go into a rack mount server or whether they're out in an industrial dirty environment or in a transportation hub, for example. Next. So a quick overview of Lanner's products. On the left, you can see network security appliances. And what these are is 1U, 2U rack mount products and desktop that are designed for some of the brands that are very familiar with. The Lanner's brand is not that well known because we build the hardware for so many of the brands that we're familiar with. And so these products work really well when we get into what's called a white box model, an ecosystem model, or a disaggregation of hardware and software. So Lanner's products can be sold to the end user, the integrator, and then they can license or deploy the software from ZEDEDA, Nozomi, VyOS, etc., to put on top and create a solution that is more cost effective because we've eliminated margin stacking. The features can be added a lot quicker than a single point solution. In the center, there's a set of virtualization computing products. These range from 2U with Xeon scalable processors up to 336 cores, for example, in a dense compute product that's used in 5G, that's used in the multi-service edge compute. Out on the right, we see the intelligent edge products. This is what we're mostly focusing on today. These are industrial products, often fanless, often have a lot of industrial protocol interfaces for them. They meet a lot of specific certifications for whatever environment they're going into, whether it's electrical immunity, whether it's vibration, transportation, outdoor environments, extended temperature. Lanner designs and builds to meet the highest quality standards so that the hardware that you're getting will meet or exceed the specifications required for that space, whether it's in an electrical substation or a transportation, a vehicle, or a telecom network, the base station of a cell phone tower. In addition, you're assured of secure manufacturing and processes through the ISO 27000 and 28000. And Lanner also meets the TL 9000 quality certs for a lot of the telecom specifications. Lanner is a partner with many of these technology leaders that you're familiar with in the CPU space: Intel, AMD, ARM, NXP. In the switching products, Broadcom, and now the Tofino switching product. In the security space, we've got silicon from Infineon and Nuvoton that provides the TPM for security at the lowest levels. Next slide. So the hardware solutions are designed for applications all around the edge, whether it's an electrical substation or extremes of temperature, electromagnetic interference, or vibration. Normal computers and routers and switching gears really won't work. They're suited for data centers or customer premise. But when you get out into the real world, these products need to be fanless. They need to last for 5, 7, 10 years. They often can't be accessed for maintenance, so they have to be designed reliably to begin with. So that is pretty much what the Lanner solution is. You can see here smart manufacturing. There's a lot of electromagnetic interference when there's pumps and machinery. So a lot of the ports on the Lanner products will have isolation design. Many of our products have wired or wireless connectivity. So for the 5G space, we already are introducing the sub-6 gigahertz to access the 5G spectrum that's being made available. Transportation networks, whether it's in the vehicle with engine monitoring, GPS connectivity, all of these edge applications need to have some sort of network connectivity. And by using the multi-core design with an orchestrator, with virtual machines, applications such as routing and security can be added fairly easily as needed to whatever level of security or routing is required, some more, some less. In addition, there's two specific products I wanted to bring up on the next slide. The one on the left, the LEC 6041B with the Core i5, i7, has already been certified by ZEDEDA and has been used to demonstrate many applications, host many different VMs. It has extended temperature range, so you can put this in -40 to +70 C. It has fiber interfaces for electrical immunity, and it has no rotating parts, no moving parts at all. It's designed for a 7 to 10 year life. On the right is the NCR 1510F. So Lanner built a network computing device for the SD-WAN space, and many different software companies have written code and deployed it throughout many networks. And so what we did is we took the same design and hardened it for the extended temperature range, added an LTE pluggable module so that it can be put onto a Verizon, AT&T, or PTCRB network very easily. It also has the same extended temperature range, but it's more of a wall mount or a rack mount design product. So these are the types of products that support the Nozomi secure software and also the VyOS routing stack, and obviously run with the ZEDEDA management and orchestration layer. So with that, I'll conclude and turn it over to Taras to talk in more detail about the routing one. I'm going to skip this last slide. This talks about some of the Lanner features of designing a specific product for you. So thanks, Taras and John.
Thank you, Tim. Thank you for the introduction, and hello again. I would like to speak today about options and benefits which you may get by consolidating routing functions with other workloads in a single hardware. Currently, most of companies use a dedicated router hardware to manage their networks, but modern devices can offer enough performance to combine routing with other functions without a productivity drain. Therefore, combinations like Lanner, ZEDEDA, Nozomi, and VyOS become more and more promising because they allow optimizing infrastructure and management processes. Next slide, please, John. Thank you. So, VyOS in this stack is a complete and fully functional router that is responsible for handling a wide list of networking functions. It has a low overhead, which do not affect overall device performance, support both pass-through and paravirtualized network interfaces for maximum network connectivity speed, can be managed in different ways, including using automation tools, and contain all the basic services and features required in typical networks. Some of them, which may be interesting for OT and IT networks in the first place, are different variants of routing, including dynamic routing protocols, which allow splitting network for small L2 domains and provide or deny connectivity between them, reducing security risks at the low networking level and simplifying devices management. Interconnections with other locations. When network infrastructure is big enough and requires a connection between remote sites or devices, VyOS can provide it with different VPN protocols like a classic IPsec or something modern like easy-to-use WireGuard. For very ramified topologies, it is also possible to use the MVPN to optimize traffic flows. A special case of VPN is remote access for road warriors and home workers. This is a very topical task in current days, and VyOS also offers several ways how to handle this. Or also handling external connections to provide, for example, access to the internet or other big corporate or private networks, like a usual edge gateway with some benefits, for example, traffic balancing between channels and high availability. But generally, you may use it not only for this, but for all the tasks which you solve with the classic hardware routers. Let's review two most common cases on how you may use VyOS in virtualized environments for OT and IT networks. Next slide, please. Thank you. The first case is classical edge gateway. A typical edge gateway covers multiple networking functions like routing, network address translation, applying different limitations to a traffic. If a gateway provides connectivity for a network with critical or important elements, it also should be ready to fit high availability requirements. VyOS have the solutions for all of this. The basic function, routing, can be done in different ways according to the available connections and requirements. For example, a simple static routing with a single connection, or policy-based routing using traffic classifications if it's necessary to use different paths for selected types of traffic, or utilizing multiple uplinks for complex topologies together with dynamic routing protocols. The most common situation are connections to several operator networks with BGP support or big own network with IGP protocols like OSPF inside. Network address translation usually allows providing internet connectivity for devices in a network and other virtual machines from a hypervisor. Less often, the ability to reach internal services like sensors, interfaces, or video streams from outside. Of course, this and not only can be done with VyOS. When connections are limited by speed or in a network exist some such sources which may unexpectedly generate burst traffic, and customers do not want to feel issues produced by these factors, QoS rules can be used to mitigate them. VyOS support multiple types of QoS schedulers, and each class of traffic may use its limit and priority, so it is possible to configure guaranteed services levels. To create redundant solutions, if high availability is required, 2 or more VyOS instances may be used to act as a single router cluster. They can be deployed on the single hardware, which protects from software errors and allows to do in-service update and maintenance, or on different physical devices, which additionally reducing risks issued by hardware problems. Together with features like LAN bypass on Lanner hardware, this allows to build very reliable services. Next slide, please. Another one important function for a router in networks with devices and services located away from each other is uniting them into a single environment. When you do not want to make services publicly available and need to be sure that traffic will be secured between endpoints, you need to use VPN technologies for this. VyOS supports multiple of them. The best compatibility with other devices, for example, when you need to seamlessly move from other solutions or has devices from multiple vendors, provide classic IPsec protocol. It can be configured using static tunnels with selectors for traffic which need to be encrypted, or virtual interfaces which transparently encrypt any traffic transmitted via them and allow to use dynamic routing protocols over encrypted channels. Authentication can be done with simple pre-shared keys or with keys and certificates if PKI infrastructure already deployed in your company. Encryption can be accelerated with Intel Quick Assist technology, which can improve total performance a lot if hardware is support this technology, of course. For similar to IPsec purposes, VyOS offer also WireGuard interfaces. They are pretty easy to configure and maintain, and provide better performance on devices without support of hardware-accelerated encryption, in comparison with IPsec. Also, WireGuard is much easier to use when a device is located behind NAT. To provide remote access to locations for mobile workers or devices can be used OpenVPN. Clients for which are available on almost all software platforms, so it can be used as a unified solution, or LTTP with IPsec encryption for those who want more conservative variants. OpenVPN can also be used for site-to-site connections, but due to low performance, this variant has a limited list of use cases. Also, as WireGuard can be used to provide access for remote workers, it is easy to implement and provide good performance, but does not contain all controls available with protocols like OpenVPN, does not can always fit requirements for mobile clients connectivity. A special case is a big topology with a lot of remote locations and traffic between them. If branches or remote sites exchanging traffic actively, not only with the central office, but also with each other, the full mesh topology is required to avoid needless hops in between. DMVPN is a technology that allows to dynamically create direct connections between peers and cut corners in a traffic way. VyOS use multi-point GRE and NHRP protocols to create DMVPN connections, and this implementation is compatible with other vendors like Cisco, so it's possible to create heterogeneous connections between different devices. Another important moment is compatibility with many platforms. VyOS can provide VPN connectivity between bare metal, virtualized, and cloud environments with the same efficiency. Next slide, please. So, summarizing available benefits and what you should keep in mind when you will consider virtualization for routing. First is CAPEX and OPEX reduce. There is no need to pay for additional hardware, licenses, etc. VyOS does not limit usage anyhow, and you will always have as much routing performance as can provide underlying hardware. The next is better flexibility. If you need to get more computing power for services or routing, all functions can be moved almost transparently to another more powerful device. Configurations will stay the same. Then it's economized resource usage. Spendings or management comfort are not always the most critical factors. There are a lot of situations when you're limited in some very basic resources, like a free space for installations or available electric power. When the router is a part of a single consolidated solution, all the resources will be shared between all the services, and total requirements will be reduced significantly. Environment automatization. ZEDEDA helps to automate services management, and VyOS provides several ways of integration with automation tools like Ansible, SaltStack, or REST API for advanced control. So it is possible to create an extended environment controlled by automation tools. Then this solution is unified. It doesn't not matter if you need to deploy services on a remote location, technical facilities, central office, or in a cloud service provider. The solution stays the same in all environments. Thus, you can use the same tools, reuse configurations, and the best practice everywhere, and do not need to read additional documentation or have dedicated personnel to manage each platform. And fewer risks. Less hardware and physical connections, reducing a chance to meet hardware-related technical issues. Also, backup and transfer of virtualized services are much easier in comparison with bare metal alternatives. Considering all the above, we think that combining routing with other services in a single hardware box, centrally controlled by operators, is a really great idea. Its implementation will make network infrastructure and connectivity ready for modern requirements and future changes. In this place, I'm freeing up the send to Phil from Nozomi Networks. So thank you.
Thanks a lot, Taras. So yeah, hey guys, I'm Phil from Nozomi. If anybody saw the earlier panel on, I think Chris Grove from our team was on there. So again, hopefully you had a chance to see it. If not, I think they'll all be posted on there. So for the purposes of this specific engagement, of course, we're going to talk about how we can play kind of in this space, right, in the IoT and OT arenas with other vendors like ZEDEDA, with great open source platforms like VyOS, and of course, great hardware partners like Lanner. So what I want to do is talk about, next slide, please. The difference between OT, IoT, and traditional IT security, right? The cool thing about what we were doing here is that we're leveraging some of those existing IT tool sets, the types of components that you're already seeing, things like, again, Lanner appliances and VyOS, with a system that's really designed to better understand what's happening inside of OT environments. If you guys have OT customers, or if you are, yourself, if you are an OT customer, you're familiar with, the difference between traditional IT security and OT security versus traditional IT, right? Confidentiality is typically the thing we're focused on the most when we talk about IT security architectures. So things like protection of data, right? Making sure that things are properly segmented are all typically the first things we'll focus on. However, in OT, it's really the opposite, right? Availability, typically kind of considered maybe a last thought for a lot of companies, is actually number one. If some of these systems go offline, the power turns off for millions of customers, there could actually be real world impacts. People could get hurt, people could actually die. So availability kind of plays into all of that, right? Making sure that these critical systems are up full time. And so that plays into how the OT and IoT environments are typically architected, where there's an emphasis placed upon, making sure that things continue to work, not necessarily a fail closed model, but rather a fail open model. And this is problematic because a lot of these networks are built with legacy systems that don't have the types of, security in mind that we would typically see in IT. IT was one of the first sectors to, adopt these newer security standards, while OT, again, was very much focused on that availability component. They weren't too worried about things like secure authentication and authorization. And of course, we see with this is a reliance on very esoteric and kind of mysterious protocols, these OT and IoT protocols that differ markedly from standard IT. In a lot of IT environments, you're pretty much going to see a lot of standard IT protocols like FTP. You're going to see a lot of HTTP and HTTPS, right? And then some of the network management protocols that go along with that. These days, most API calls, even if we're talking about web services or hybrid architectures, still take place over traditional TLS encrypted sessions, which again, most IT systems will support natively, right? And then as we move more into IoT, away from traditional OT, but IoT, the scale is also exploding, okay? We're going from, traditional OT environments to IoT environments that may have hundreds of thousands or millions of connected devices, especially as we get into those newer 5G networks that Tim was talking about earlier, where you have that huge box there providing mobile edge computing services. So again, we're dealing with a set of challenges that the IT community historically has not had to deal with. And as a result of that, there was not a lot of software, not a lot of solutions available to address these challenges. Next slide. And so that's where Nozomi Networks comes into play. Our focus is on OT and IoT. From the beginning, that's what we were designed to do. Both of our co-founders came from those spaces. They both received PhDs in computer science as well as ICS cybersecurity, and then wound up working in the industry. Either in one case, it was an oil and gas company. The guy was the director of cybersecurity for that. In another case, the other founder was doing research and development on power control systems for the European Commission. And so we were founded, really to address this capability gap, which was being able to see and detect threats inside of OT and IoT networks. And we do this a couple different ways. Next slide. With our flagship product called Guardian, we provide a number of different capabilities designed to give you a more holistic idea of what's happening inside of these networks. We're going to monitor all the traffic in real time and then help you understand how devices are communicating. In a lot of cases, maybe you have a system that was installed 10 years ago by a vendor that's been acquired 2 times and is now under a large automation vendor. And since then, you have no documentation, right? A lot of our customers lack documentation. And you need to figure out what is actually communicating on the network and how are they communicating. And so that's kind of the first part, is to identify, what is the network traffic? How are the devices talking to one another? Once we move past that, we can begin to build a better understanding of the devices on the network, looking at how the devices are actually represented in terms of firmware versions, serial numbers, make and model, right? Even going so far as to see which components are actually installed on some of these programmable logic controllers and other types of OT embedded systems. This also includes things like vulnerability detection. So being able to say, okay, this version of firmware is vulnerable to these types of attacks, and then helping you put into place the appropriate mitigation measures through, again, actions like proper segmentation with a platform like VyOS in order to prevent or mitigate the risk of attack and exploitation against these vulnerabilities. And then finally, with all this in place, right, once we know how the devices are communicating, how the devices are actually configured, we can detect threats in real time as they occur through anomaly-based intrusion detection combined with research provided by our threat intelligence team in the form of more traditional signatures. Of course, in the end, this is all well and good, but we're a passive system that sits out of band and runs, again, either maybe a hardware appliance or, in the case of this solution, as an embedded service on top of a consolidated workload platform. So how do we actually help react to events as they occur? Well, that's going to be through integrations with platforms like VyOS, allowing us to move in real time to respond to threats as we see them. Next slide. And so again, whether you are running a managed security service, whether you are yourself an end customer that's leveraging the ZEDEDA platform combined with these other services, the key thing here is that we're, together, our story is that we, ZEDEDA, Lanner, VyOS, and Nozomi, want to make sure that we can address all of your basic requirements for IoT and OT, whether that's going to be deploying a large number of cost-effective appliances or deploying very high-powered consolidated monitoring in your 5G backbone or something like that. Next slide. So let's take a second to double click on the integration between Nozomi Guardian and VyOS. I mentioned before that reaction is, of course, very important. We want to be as proactive as possible, but a lot of times it's very, very difficult to, go into a brownfield scenario and be able to put in things like microsegmentation and other types of control measures that we would expect to be represented in a good, robust network model. And so one of the things that we can do if we're in a greenfield scenario is integrate with VyOS in order to provide rapid policy recommendations for segmentation, looking at how devices are communicating, and then basically saying these devices should be permitted to talk over this layer 7 application or this layer 4 port, and then instantiate access control rules to make that a reality. Of course, we can also synchronize things like asset details in different zones that we've identified or configured in order to make it easier to create firewall policies on an object basis versus sitting in there and plugging in every single IP address and layer 4 port. Now, again, this is more on the preventative side, right? So we're going to try to, through this, we're going to try to segment networks properly and restrict the lateral movement capabilities of an attacker. However, breaches do happen, and they're going to happen inside of your OT and IoT networks for sure. And so one of the things we can do is as we detect threats, we can reach out to the VyOS firewall. Again, we're there locally on the appliance, so it's a very, very quick connection for us. It all takes place transparently without needing to open up a lot of ports everywhere, and then tell it to block specific connections that are a threat. So if we see, somebody opens up a new SSH session to a device they shouldn't be, we can tell, hey, block this. If somebody tries to modify the function code on a controller to change the functionality of that controller, we can tell them to block that specific function code, right? And then at the end of the day, this all results in that concept of secure data routing. So we're making sure that we're properly segmenting the network, that we're able to block attacks as they occur. And the result is that we're going to try to mitigate the risks associated with operating these OT and IoT networks, which historically have been kind of a wild west for attackers that are able to get inside of them. Next slide. So what does all this look like when we put it together? All right, if you've worked inside of OT, if you have OT networks or if you have OT customers, you're probably familiar with the Purdue model. Well, this solution is going to focus at all levels of the Purdue model, from level 1 all the way up through level 4. And that's just due to the capabilities that all these different solutions bring together to the table. So Lanner provides, again, a wide range of ruggedized appliances, which make them very suitable for deployment at things like remote substations, Alternatively, they have very large, powerful solutions that can be used in network cores. And then the VyOS solution allows us to provide segmentation on both a transparent and layer 3 basis throughout all these networks, making sure that we're restricting access between level 2 and level 1 only to those devices that actually need it, to ensure that people aren't given free reign to move up and down from, say, a Windows workstation they may have compromised in level 3 DMZ and quickly jump down to level 1. And finally, ZEDEDA gives you power to quickly orchestrate all of this together by deploying, in this case, these 3 microservices on Lanner hardware without having to go and physically sit there and install everything. Next slide. And so just to summarize, right, what we've got here is we've got all the solution leaders in this space. We've got ZEDEDA providing the orchestration capability and the virtualization layer. We've got Lanner, who's renowned in the ruggedized and, of course, high density compute space. And we've got VyOS, which has been around for years and is the leader in the open source routing and firewalling community. All of this results in a much cheaper end product for you. So because we're not worried about buying discrete hardware systems, right? We're not cobbling together 5 different vendors to try to achieve the same thing. It's very, very, very low cost to deploy, and it can scale on a very cost-effective basis. And because we're putting all these systems together, it makes it very easy to make sure that information can get to where it needs to be. Whether it's going to be forwarding additional logs to a SIM, you know that it's all going to come from a single data source rather than having to worry about pinholing firewall rules or creating separate zones throughout your network. We're consolidating all this workload on a single appliance to make it easier to federate data to third-party systems. Of course, since we're deploying the firewalls across the customer's network, it's going to make it much, much easier to actually secure the connectivity within the OT and IoT networks. And then finally, because we have that API component, it allows us to reuse or repurpose the virtualization layer as well as the hardware as we need to add or remove services. So again, from a scalability perspective, it becomes much, much cheaper. So I'll turn it back over to John and Tim to close it out.
Yeah, Phil, thanks for the summary there and the recap. Tim, Taras, Phil, great job today in the sessions. We really appreciate your support with this event. I think it was great education for our customers and for ourselves. I think we got a couple follow-ups from the Q&A that we'll go after, but with that, unless someone's got any closing remarks, I think we'll close this session up. And again, thank you for your participation today.
Yeah, John, just one thing to add. Cost may be a driving factor for some of our customers, but flexibility is another one. You may not know what services you'll need to add as you deploy out, what security threats will come down the pike, what networking protocols will be needed. And so having a scalable and a flexible product like the Lanner running ZEDEDA, it's much easier to add remotely new services, new protocols, new functions on top of this system rather than the fixed function boxes that people have been used to in the past. So it's not just cost, it's the future, it's expandability and flexibility that I'd like to highlight. And thanks to Taras and Phil for doing a great job.
Thank you, Tim.
Great, thanks, Tim.
Thanks for having us.
All right, thanks everybody. We'll close this out. Have a great day.